So Exversion is basically a platform for data, because I love data, but data is really messy, especially when you're trying to figure out where it came from, who collected it, what their thought process was when they were defining the different categories and figuring out what to collect, and how does it relate to other data from other organizations. So in terms of working within the nonprofit sector, what we would find is that a lot of nonprofits, and actually a lot of developers in and of themselves, like to sort of employ a lot of crowdsourcing with data collection. It's like, okay, well, we have a lot of volunteers, and so we know what data we need, and we're just going to send them out and collect the data and bring it back. It maximizes their resources, and it encourages collaboration, but it also creates kind of a lot of problems. So right now in the tech community, there are a wide variety of organizations and initiatives trying to solve these problems for nonprofits and for the government sector, trying to make data friendly for developers, but easy for these organizations to collect. And so what I really wanted to talk about tonight was this idea of tech for non-tech, because that's really what our focus is at Exversion. We are building a platform that allows you to access data through an API. So we want to make it as easy as possible for developers, but the vast majority of people collecting the data are not technical organizations. They're not technical businesses. So we have to sort of work within their parameters. There's something that I like to call engineering utopia, which is when you put an engineer on a social good project, they want to do it like the perfect, ideal way. They want to use like a fancy new language, like they want to use Node or Go or Clojure, and I love Clojure, but they want it to have like a really powerful interface, and then they want it to be open source and free. And all of these things are great, but sometimes it means that the solution isn't exactly viable for the organization. The example that I really love in the data space is a project called DAT, which is all about tracking versions within data. And it's great, but it's a command line tool. And I don't know many people in government organizations and nonprofits that know how to use command line tools. So it sort of becomes this like, oh, this is great for programmers, not so great for the organizations that you want to help. On the other side is the reality of nonprofits. People don't want to move to a new technology because it means you have to spend time and energy learning the new technology. And then if it goes away, like if the organization that built it goes bankrupt or the developer moves on, you may have to now learn another new piece of technology because you have to adapt. The features need to be clear. It needs to have an intuitive interface. And open source is wonderful, but the web is filled with thousands, possibly millions of open source projects that someone went, here, I open sourced it, and that was the extent of it, and they just kind of died and they weren't maintained. So it also needs to be maintained. So for us, it was the technical challenge that we faced was sort of like, how do we bridge these two worlds? How do we give the developers as much of the utopia as they want while making it easy for the nonprofits? And one of the big things that we started learning when we were talking to nonprofits is that we had to be configurable with their existing tech, which was very, 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 not necessarily low tech, but not like the powerful, impressive tools that are available for what they wanted to do. It had to be easy to use, and it had to be something the developers could build on top of pretty easily. And we had to give the organizations as much control over their data as possible. So I'm going to talk about two organizations that we are working with specifically. The first is a very tiny nonprofit in New York City called Literary Manhattan. They have super cool data. What they're doing is they're going through books and looking for like place references within the books, and then taking the page number and the line number and getting the geo information about the place so that you can like load up a map of all of the places that are mentioned in the book and kind of do a walking tour of like breakfast at Tiffany's, for example. So it's like really super cool data, but it's all hand collected. They basically sit there reading books, highlighting, and then like typing it in a spreadsheet. And they have lots of volunteers, lots of people who are willing to help them with this. But the problem for them is that they need to be able to sort of check that the volunteers are putting correct data into the spreadsheet. It's sort of a Wikipedia issue. They need a place to kind of like moderate that content. On the other hand, we have NYU's Sandy Superstorm Research Center, and they're dealing with organizations that are on the ground, kind of disaster relief organizations that are collecting all of this data. And they're trying to aggregate it from multiple agencies and from multiple sources, and then distribute it to whoever's interested. But there's also some data that they need to restrict and keep private. So we have two use cases that are very different, but they come to sort of the same core issues, that a lot of this data is not being stored in a database, it's being stored in a spreadsheet. And if they do have collaboration, the best we're getting out of them is they're storing this data in a Google Doc and then just sharing it to all of their collaborators so everybody has access to the Google Doc and everyone can edit the Google Doc. So we came up with this idea. I was like, well, why don't we just sync with Google Docs? Then you can have your Google Doc, and you can create a Google form if you want to have a user interface on your website, so people put the data into the Google Doc, and we'll sync with it so that our data repositories are pulling the data from the technology that you already know how to use. You're already comfortable using it. And then we can use our API to sort of give you a flexible layer that can be built on top of it. You can build apps on top of it. You can build other collaborative tools. And you can also control the data through our API. So without further ado, I'm going to show you around a little bit. This is actually the platform in action. And we have kind of like a wide variety of really, really super strange stuff, like NASA locations within the United States, all accessible through an API. And I like to use this data set because there's something funny about this data set. When I said data is messy, I don't just mean like logistically, I mean actually messy. So in this data set, we have states as a parameter of the data. And so we have abbreviations, but also apparently someone did not realize what the abbreviation for Ohio was, and so it was just Ohio. So one of the big aspects of what we're building is this idea of version control, this idea that like in GitHub, you should be able to branch a data set, make changes to it, clean it up, get the correct abbreviation for Ohio in this data set, and then people are still able to access that data as well while tracking what was changed, where the data came from, and ensuring the provenance of the data set. So we can also access data sets that we don't host. Like this is on Socrata. This is a really amusing data set. This is pigeon poop in New York City. So I love showing this one off because it's so bizarre. It's all the incidences of pigeon poop in New York City. They basically aggregate all their 311 data, and then they separate it into categories. And I'm not sure who decided that pigeon poop was the category to go with for data, but I'm glad that it exists because it's super amusing. But anyway, back to the syncing. So what I'm going to do is I'm going to show you how this works. Now this is a feature that has not gone live just yet. In fact, I was debugging it this afternoon. So I'm secretly afraid that something will go horribly wrong right now, but hopefully it won't. So let's see, devs for good demo. I'm going to demo Google Doc syncing. Say Google Drive is the source. We try to find the sweet spot between, when it comes to metadata, between too much metadata and not enough metadata. It's really important to have the idea of where the data came from, but we understand that people don't like filling out lots of really long forms, so we try to do what we need and nothing more. So all right, now I'm going to tell it I want to sync it from Google Docs, and I'm going to keep it private because this is a demo. And what it's going to do is it's going to load up all of the spreadsheets that I have access to on my account. I didn't show you the actual OAuth, but we've all seen OAuth before. It's like I accept and then go through. So I can pick now any of the spreadsheets that I have access to. I think I'm going to go with this one. And now it'll pull up all the worksheets within that spreadsheet. So we're going to with competitors. This is a Google Doc between me and my co-founder listing all of the people that we think are in competition with us. So now I'm going to import it. This may take a minute depending on how fast the Wi-Fi is. Here we go. OK. So now it has taken all of the information from that Google Doc and loaded it into our system. This, by the way, is what the Google Doc looks like. Just to like confirm that this is actually a legitimate thing. So I can now access this data through an API. So if I, for some reason, wanted to build an app of all our competitors, I could do that. Let me see. Go away bar. We'll go with name. So give it a parameter, and I say, I want CCAN's data. And now it'll pull up CCAN's data as a nice little string of JSON, and I can build on it super easy. But one of the things that we allow is for editing of data sets through the API. So I can actually change this data from Exversion and then have it update the Google Doc dynamically. So I need a couple of things. And I need the ID number of the data set, the data point that I want to update. Okay. So those are the two things I need. I need the data set's ID number, and then I need the ID number of the data point itself. Both are available from the API. It'll tell you the ID number. So that's pretty easy. And now I need to figure out what I want to change. Well, currently, let's see, I'm going to change CCAN. And CCAN, it's listed as it's based in London. Well, let's say I look at that and I'm like, well, that's not right. It's not based in London. It's on the moon. So I'm going to change this to on the moon. And I send the request. And it says, OK. CCAN is now on the moon. And here we go. On the Google Doc, it's been updated. So that is basically what we're working on now, is pulling in as much syncing functionality so that our nonprofit stakeholders don't have to change their current technology in order to be able to give people access to their data really easily. And I think